Welcome to NatureBacked, Alex. Tell us, what are you building?
Oh, thank you very much for the invitation. Really appreciate being here. We're building what we believe is going to be probably one of the most impactful technologies that requires relatively, in fact, no capital from a deployment perspective. We're specifically targeting the concrete industry, an industry that uses a product called cement that on its own is responsible for roughly 8% of the world's global emissions as it relates to CO2. But probably, just as importantly, concrete as a product is the second most consumed product on the planet after water. But it's directly responsible for a lot of positive things. If you think about so much of our infrastructure, so much of the things that, even the Romans with aqueducts have given to us in terms of, improving infrastructure, getting water to places that were unable to get it before, enabling better distribution channels. These are things that concrete has been able to, deliver to the planet, ultimately have a huge impact from a longevity perspective on human life. And so from our perspective, there's huge value in the product. What we're going to do is just find a way to kind of initially reduce the amount of emissions associated with it, but in the longer term, really think about it as a carbon sink and effectively a vehicle for us to start removing carbon out of the atmosphere and embodying it in the built environment.
I mean, probably no question about the fact that the concrete's role in the carbon emissions. But how do you what are you changing there in the process?
Yeah, so obviously this is kind of the vision. What we're doing is we're bringing a unique functionality that AI allows us to embrace within concrete design. So we're not talking about the production side of things. We're the stage before that. We're thinking about concrete effectively as a cake mixture. And if you think about a cake mixture, you've got these various ingredients that go into it. Depending on the type of cake that you're going to make, you have different ingredients. The constants are always there. So in a cake, you're always going to have egg, you're going to have flour, certain sugars and spices and stuff like that. In concrete, it's the same. You have cement, which is the same as the egg. It's this binding agent that keeps everything together. You have the flour, and the flour is going to be analogous to aggregate, which are the rocks and the stones that make up the vast majority of concrete. And then you have water and chemical admixtures. And these chemical admixtures just provide different properties to the concrete. What people don't really appreciate about concrete is that you actually have a totally different recipe depending on the application. And by that, I mean, if I'm building let's say a commercial skyscraper, for example, I have columns, I have beams, I have stairs, suspended slabs. Each one of these has different properties from an engineering perspective. And these different properties require different concrete formulations. So, for example, in a beam, I need to get to a certain compressive strength at 28 days. In a column, I probably want to get to the same compressive strength, but in 3 days, because that member within my construction building process requires me to have a higher early strength. So the actual formulation that I use for that concrete is different. So what we do is we bring the power of artificial intelligence into this environment. It's historically been a very experimental world where people will literally make a sample of this product in a laboratory, test it after 28 days, which is the typical standard. And then if it meets the requirements, either put that directly into production or they may refine it a little bit better to try and get to a low cost. Because, the area of artificial intelligence that we're working in, which is really a branch of machine learning, allows us to model in multiple dimensions. And we're not limited to the number of dimensions that we can model in. We are now able to take all the different types of information associated with the different raw materials. So those ingredients I spoke about in this kind of cake mix, and allow a producer, based on their engineering requirements, to come up with the optimum mix associated with the materials that they have physically available. So at this point, what we're not trying to do is reimagine what we could do. That's definitely the next phase. with different types of materials, because those different materials are on the horizon, and probably in 5 or maybe 10 years in some cases will be available at a scale that can really help substitute that cement, which is, two things. Cement by cost is the most expensive product in concrete. It's typically anywhere from 40 to 60% of the cost, depending on the amount of cement that you actually require in it. But if you look at it from an environmental perspective, it's always north of 90, sometimes north of 95% of the embodied CO2. So this really becomes a big opportunity going forward in the future. Right now, it's just about what we can do today. And it's kind of, it's first do no harm. Let's see how we can reduce the impact as much as possible. But in the future, I really firmly believe that the journey is going to result in us having these different types of materials that allow us to substitute for cement and ultimately allow us to have CO2 being part of the mineralization process and actually included in concrete.
How far are we in the search of those alternative materials for cement?
Yeah, pretty interesting. There's a lot of work being done. In fact, the entity we are affiliated with, UCLA, which is part of the University of California system. This one specifically is based in Los Angeles. We have a spin out called Carbon Built. Carbon Built actually won the X Prize in 21. And this technology is focused on a type of concrete, which is known as precast. So in this case, these are blocks used for construction. And what they're actually able to do is capture waste CO2. In most cases, in their case, it's from biomass that would typically be, degrade or be burnt. So they actually capture the CO2 from that biomass, and then in a curing process, introduce that CO2 into these blocks, and the CO2 is actually absorbed. It helps the mineralization process. And then in every block that probably weighs, let me do the quick conversion. So somewhere between 7 to 9 kilograms, they're actually able to uptake, anywhere up to half a kilogram of CO2 using this process. Obviously that's a challenge, because when you look at that market, for example, in the United States, probably around 10 to 15% at the most of cement consumption is that type of concrete precast. The vast majority is ready mix. And so ready mix is these trucks that everybody sees with the big drums turning around, going down the road. That's anywhere up to 75%. But the really important thing about a product like Carbon Built is demonstrating the efficacy and now being able to scale it, because, you're not just avoiding emissions. This is true emissions reduction. And so that's a total game changer in terms of a pivot. There are other cement substitutes that are coming online, just off the top of my head, there's companies like Sublime, Forterra, and I think we're going to probably be some, at scale with those kind of product in terms of being able to get, demonstrated, quantities that we can actually start testing with. Definitely within the year. I mean, people are talking about somewhere, 20 kilograms of wheat production probably by the end of this quarter, which is enough to start working on. But, you got to put things into perspective. When we talk about scale, we produce 3.5 billion tons of cement every year. Billion with a B, not million. Right? So this is always going to be the challenge, is how are we going to find a way to start substituting, and how are we actually going to find a way to start doing this in a way that's really going to have a meaningful impact. Concrete's not going anywhere. That's just the reality. You could look at every projection from, the World Cement Association. It doesn't matter who you talk to. Compound annual growth in this industry in the region of 4.5% to 5% through 2040. And that means, in the next 20, 25 years, we're probably going to have the same amount of buildings on the planet that we do today. So we're going to literally double that number of structures. And I mean, this is a function of people coming out of poverty, of economies getting stronger, in particular the global south, as they have higher energy demands, as people have more, relative wealth, they're going to need more infrastructure. And so this is something we can't ignore. It's something we have to be active about today.
Is there alternatives to kind of at scale? Because as concrete is such a big part of the whole carbon emissions and kind of demand is growing 5% a year, I mean, can we do anything to actually replace it in some level? Wood?
I mean, at some level, yes. I think the challenge you have with wood is scale. You know, the US is a great example. Yeah, exactly. I mean, the US is a great example. I mean, from a residential perspective in the United States, most structures are wood, but they all have some concrete in them. You know, you can't have a wooden foundation, for example. And this is a part of the challenge. So there's probably a hybrid wood steel, but, you know, per kilogram, steel's got a higher associated footprint because of the amount of energy that you require. So, I think this is always going to be part of the challenge. And this is also something I think that, you know, folks like myself who have the privilege of working in a society that's, you know, hyper industrialized and has had the benefit of access to energy and access to products. We have to think about, you know, finding the solutions here and being able to deploy them in places that don't have that access right now, but are going to have it sometime in the future. So, you know, when we do that deployment, how do we do it help those folks do it with the least impact possible on the environment?
One more general question before going more into what your company is doing. Is there kind of recycling opportunities? Can we reuse the concrete? You know, if we demolish a bridge to build a new bridge, can we use the same concrete?
So the answer is to some extent, yes. There's some companies that are doing some really, really good work on circularity, specifically within the built environment. I used to work for a company called Holcim. It's a Swiss building materials company, and I think if you have a look at what they're doing on that side of the circularity equation, it's becoming really evident that there's massive opportunity for this. You know, one of the challenges with concrete is, you know, the ingredients that make up the vast mass of concrete are the aggregates and the sand. And so these kind of are items that provide some, let's call it structural integrity. When you have a paste and, you know, the paste that binds the sand and the aggregate together, that can be a bit of a challenge. But what it means is that you may not be able to use it in the same application. So, you know, if I gave that example earlier of a building, well, you could take the concrete out of that building, and even the concrete that's got reinforcing in it, there are ways to separate that concrete from the reinforcing and recycle the steel. But you may not necessarily, well, you definitely don't want to put that same concrete back into, you know, a high demand engineering element. But what you could do is put it in as a base course for a road, for example. So there is ways to reconstitute it and have a different kind of application for it. Even though it may not necessarily be exactly the same original application, you can find another one. And it could be, you know, backfilling a structure, you know, for, you know, against a foundation or something like that. These absolutely exist.
We'll do a quick break now to get a few messages from our advertisers, and we'll be back in a minute.
Life is hard, but finding a really great podcast makes the days go by so much easier. Hi, my name is Blue Telusma. I'm a writer, an emotional intelligence coach, and the host of Humanize with Blue Telusma, a podcast where we believe that when you humanize everyone in the room, a great conversation is almost guaranteed. Join us every week here on Electricast as me and my guest co-hosts unpack big topics and interview even bigger personalities with a sense of humor and a dash of mischief. If you're looking for a new best friend in your head, we've got you covered. Electricast.
Welcome back. Alex, you talked a little bit about how your company is basically optimizing the use of cement in the concrete building. But could you go a little bit into the more details to tell, you know, how the idea was born, how the company was born?
Sure. So the idea has been in circulation for a while. Certainly, my colleagues at UCLA have been thinking about this for the better part of a decade. I'd say for me that the kind of the aha moment happened sometime in 2016. I actually saw an article by a gentleman called Ray Kurzweil. I don't know if you're familiar with him. He's, the Singularity is some fantastic future-looking books. But he actually had a photo of one of the professors from UCLA, a guy by the name of Gaurav Sant, and he's holding this. And I think the article heading was something like the future of concrete. At this point, I was working for Holcim, and I just saw this article. I said, right, what are these guys doing? And this was the genesis of the company that became Carbon Built. So the introduction of CO2 to assist in the mineralization within the precast concrete. And long story short, within a couple of days, I was on an airplane, came out to UCLA, met with these guys, was super interested in what they're doing, and then the actual concept of how we could think about applying elements of artificial intelligence that look at the underlying ingredients properties and how they combine with, in different ratios with one another. If there's a way to get enough data, is there a way we could potentially model outcomes and determine a way to, optimize the product? And so that for me was probably sometime at the end of 2016 that didn't occur to me, that got explained to me. But I really appreciated what the guys were trying to do and was able to, get permission to provide some initial data sets, that the guys started working on. And I stayed involved with them through various companies over the course of 4 or 5 years until in 2021, the opportunity arose to actually take this into a commercial space and actually start thinking about proving from a commercial perspective and a series of pilots that we needed to do with producers that this could actually work. But it's I wish everyone bought into it. It's a challenge, and the only way of doing this is by continuous repetition and validation that the process works. And so in 2022, 22, the guys started working, doing a number of pilots. We managed to secure some funding and get with multiple producers throughout the United States. And then in 23, we actually managed to convert these to some commercial agreements that we've put into place. And actually, through the course of a year, we're actually now up to having our software in 18 different operations. We're obviously looking to grow that a lot quicker. But I think what's really important about this is that we've had to take an outlook that we need to provide commercial viability. And in doing that, be able to demonstrate the opportunity from a CO2 reduction perspective. So, as I mentioned, because concrete has cement as its key binding agent, not only the most expensive ingredient, but the most detrimental from a carbon emissions perspective, it stands to reason that in reducing the amount of cement, you're going to be able to get this cost reduction and in parallel, a CO2 reduction. And slowly but surely, this message is definitely starting to permeate into our sector. And, for us, as we've been, really fortunate in the last couple of months, we've had exposures to different countries and just finishing a pilot in Canada and hopefully going to be able to convert that into another commercial agreement with them soon. Ended up getting a second commercial customer at the end of 23 going into 24. Yeah, and so for us, the momentum is really starting to build. The deployments are happening a lot quicker in terms of being able to access a client's data. Pretty exciting. Looking forward to what this year offers.
Do you have similar companies you compete against, or is the competition something totally kind of different?
No. Look, there's absolutely competitors out there. I think what's really different between us and them is that ours is not a hardware approach. Mm-hmm. We truly believe in the power of the data. And especially in Europe and the US, even in India, we're starting to see the data coming out of there that we're busy working on. But the reality is that, this is a product that is engineering controlled. And by that, I mean, there's an actual sign off on design. So before you produce this product, someone actually has to validate, and they're typically a professional engineer, that this is going to meet this performance requirements. They're only able to do that because there is very specific code requirements around the construction elements, but also because these individual raw materials are supplied in accordance to a standard. So EU standards would apply to the aggregates of cement, the cement substitutes, different chemicals. In the US, we have ASTM. And so because there's all this data that's associated with us, and we literally are able to access decades worth of data going back for our clients, not only of the different products that they have currently, but even past products and then test results, we are able to amalgamate all this data and put these into our different models, and then ultimately arrive at these outputs. And, pretty exciting for us is that over time, as we get more data and we also have to scrub some of the data. Some of it doesn't make sense. And so we're refining that process. But, all of a sudden what the AI is able to do for us is provide totally new design. So this is the different set of models. These are not just predictive models that are telling us how existing stuff is going to perform. These are truly generative models that give us new reimagined designs. The beauty about this is for me, this is one of the challenges people have with artificial intelligence, because they don't know if it's lying or not. Right. So even we're seeing a whole lot of the stuff that's going down at the moment where the AI has actually created reference articles that don't exist when it's asking people about different people and people inquire about different people. And so for us, the good part about it is because we've designed this entire software system to fit into a producer's existing testing methodology, you still have to take this new imagined product and test it. You got to put it into production. So you do that in the laboratory, or you do that out in the field, and actually have a physical product, and then you get to physically test that product as well. And for us, that's kind of excuse the pun, but it's a concrete application of artificial intelligence. It's going out there. We're generating these new mixed designs based on what the customer is looking for, and ultimately not only saving them a lot of money, but reducing waste and able to reduce carbon in some cases by up to 30%. The one thing we've also been really careful about is this industry, and I think this goes for construction in general. I mean, it's somewhat slow to react. It's a very conservative industry, and this is you're dealing with people's lives and livelihoods. You can't afford to make mistakes. And so the one key element that we've introduced into our software is this. I wouldn't call it a counterbalance, but what it is basically a check and a balance. You have this artificial intelligence that's doing, massive computation, very high speed, getting literally millions of permutations out. But you still need a human being to apply some judgment to that, because, weather conditions may or may not be changing. A client likes to have a certain finish on their concrete in order to get a certain application on the floor, or a certain time that they want to get things done. So we still allow the client to go into the software and adjust engineering constraints within it. Well, not necessarily engineering constraints, but there may be constraints on the ratios of water to cement, the mass of certain type of aggregate, how long things are going to take, what strength do I need at one day. We allow them that functionality to actually go in, and then it's just a case of the models being allowed at time just to go in and re-optimize that design based on the new constraints.
We'll do a quick break now to get a few messages from our advertisers, and we'll be back in a minute. Welcome back. It's fantastic to see the kind of AI's opportunities, or how AI is changing the world already. Is it also changing the, construction outlooks, or let's say, you're applying it for the kind of what's inside the kind of building material? Are they these days already kind of designing the buildings, or creating the designs of those concrete blocks using the AI and making the unimaginable things for the humans?
I don't think it's happening at a mass scale at this point in time. I think what you will see, and for me, 3D printing is a form of AI. Right? It absolutely is. But if you think that concrete is still, and I personally absolutely believe concrete is going to be relevant in 25, 30 years time. If you think of the convergence of 3D printing and artificial intelligence from an optimization perspective, and then new materials that are being designed and reimagined right now, I think that's really that convergence is going to be the ultimate win, because, you know, one of the realities of concrete is it's mass inefficient. So if you look at a large column on a building, for example, it's square, you know, it's typically, you know, square and a tall, cylinder strut. Now, when you look at it from a loading perspective, it's probably got 40% too much mass, because when you put that in compression, it's really only the internal part of that beam, that column that is taking the load, right? So you've got this mass that doesn't really make sense. And I think this is the beauty of where this convergence of technology is going to go to, is if you can have this 3D printing component that you can do at speed, and obviously you're going to need the scale as well, you can effectively print the most optimal shape. It may not be the most beautiful. Let's just also understand that it may not be the most beautiful in concrete. It can be beautiful in its brutality, right? But you could also then print tension into one part of a beam, for example, and do away with reinforcing. And so, yeah, I think these things are going to happen. You know, I think we get clever over time and we learn things a lot quicker. But is it here today? Just some extent, a little bit, yes, but not at scale. And, you know, this is why I think technology like ours probably has the most immediate impact, because we literally could apply this technology globally, and you could deploy this within 2 to 3 years across every operation. You know, even if a company is using an Excel spreadsheet, if you've got enough resources, you could deploy this and literally have an impact of 500,000 tons, 500 billion tons of CO2 reduction in 1 year. I mean, that is just the reality.
So all the listeners with your cement factories, make it happen. Connect to Alex and let's change the world one factory at a time.
Yeah, well, it's actually the concrete producers that we're going to get help. So the cement producers are the guys supplying it, but the concrete producers are the guys that are
mixing it.
And yeah, no, it's a good thing. People learn the difference between cement and concrete by the end of the podcast. It's very good.
As we start to wrap up, looking ahead into the 2024, what are your main challenges or the milestones you guys want to reach?
Yeah, so obviously for us, it's really about deployment and getting our technology into as many operations as we can. We like I mentioned, we're 80 in operations right now. We're trying to get to about 85 by the end of the year. You know, and the real opportunity within that is being able to show producers, look, you can ultimately, you don't have to choose between profits of the planet, right? This is something that we want people to experience. So for us, it's really having to do pilots, and once people get to understand the value of that product immediately at one location, it's a really easy thing to deploy. You know, for us, the challenge is really just getting the demand out there, and so for that reason, we have one group which are concrete producers that we obviously work with directly to understand both the economic benefit, and in many cases we have a producer, for example, in Chicago, that there's already the demand in that specific market for lowest embodied carbon concrete. It's not massive by any scale, right? It's I probably want to say maybe less than 10% of the demand, but it's growing. And what we then done is we go into the other side of the equation. We're actually talking with people that own the buildings. And so one of the, in fact, our very first client was a customer called Compass Data Centers. And you can imagine, a data center, there's continuous demand for them, lots of concrete in these, operations. And we've been able to consistently give them an additional 20% saving on their CO2 load. And so I think, for a company like that, that's already starting off and they've already got a really low base relative to most other companies. for that specific product, to be able to go in there and then demonstrate an additional 20% saving, that's been great, because that's kind of a word of mouth experience, and people start seeing that and actually want to start deploying that.
Absolutely. I think that's a good point to wrap up this discussion. Thanks, Alex, for joining us today, and I hope everybody understood the difference between the cement and concrete.
Thanks, Tom. I really appreciate your time.
Welcome, explorers of the human experience. This is Let's Talk Soul, and I'm your host, Claudia Monticelli. We're not afraid of the great mysteries of existence here. Soul versus consciousness, we're on it. Spirituality versus science, we've got that covered too. Join us in navigating these profound topics with wisdom, curiosity, and a dash of audacity. Whether you're a spiritual veteran or just starting your journey, Let's Talk Soul is your passport to the unknown. Let's Talk Soul, diving into the depths of the human spirit. Subscribe now wherever you get your podcasts.
Hey there, I'm DC. I host the rock podcast, Back to the Arena, The Interviews. It's about a 30-minute podcast where I talk one-on-one with a band who has released new music. You can find us on all the best podcast sites like Spotify, Apple, Google, iHeartRadio, and more. If you're a rock fan like me, subscribe today to Back to the Arena, The Interviews.
Electricast.